Okay, I've just recorded the session, so for every one of you who cannot come to the class today, can still catch up with the review session that I put out. So today's session will be 6.6 and 6.7. 6.6 should be inverse trigonometric functions. For those of you who watch online live stream, tell me if there's any problem with it. Okay, so we start out as six, which is we all know that inverse function only happen when the original function is one-to-one function. Wow. So when we take a look at the trigonometric function, the first function we should take a look at is the sine function. So the graph of sine is like this. So by looking at this graph, we know that this function is continuous on this part of the graph. Actually, sine function is continuous everywhere. So this is a one-to-one function, therefore it will have a inverse function. We will denote the inverse function of sine as sine x equal to y. So that means sine y will be equal to x. So when you look at this one, you see that y is actually the angle, and x is the value of its sine. So y will range from minus pi over 2 to pi over 2. The range of the inverse function is very important for your further calculation. So keep in mind all the range that you will be given in the textbook or everything else. It's the definition for the inverse function of sine. So let's let's go to one example in the book. So if example 1, example 1 should be evaluate the sine minus inverse function of sine. Sorry. Evaluate these things. So we all know that sine pi over 6 is 1 over 2. So the question, the answer for this question is very simple. It will be pi over 6. So we have this one equal to pi over 6. The second question is a much more interesting one because I think the professor will ask this question in the exam or in the quiz because it is very unique one. So the second one is evaluate tangent of arcsine of 1 over 3. This question can be done by a very simple way, by using a Pythagorean theorem, and let's just assume that. So you have this one is an angle, right? Is an angle. As you see in the definition before. So let's assume that theta is that angle, is the arcsine of 1 over 3. So which means that sine theta will equal 1 over 3. Which, to solve this problem, we have to draw a triangle. So we know that sine will be the opposite sine over the hypothesis. So when we draw this triangle right here, and we assume that this is the theta angle, this is theta, we know that the opposite sine, the sine of theta will be 1 over 3. So this sine will be 1, and this sine will be 3. So which leads to this sine this the remaining side will be 2 square root of 2. It is because this one is equal to square root of 1 square plus 3 square. This is a Pythagorean theorem, so it should be easy for you guys. When you have calculated this one, you will know that. So when you know the value of the 3 side, you can calculate the original problem. So the original problem will be 10 upside 1/3, right? So which equal to 10 theta. Oops, I made a mistake earlier about the sign. That should be fine. So when you look at this triangle, the tangent of theta should be equal to 1/2 to the square root of 2, which is this side over this side. This side over this side. So that is the first example of sine. So the next problem we're gonna tackle is the derivative of the inverse function of sine. So we assume that y is equal to inverse function. So how can we find the derivative of y? So by definition, we have that sine of y will be equal to x. So when we differentiate both sine by x, with respect to x, we will have that this one will be cosine of y dy over dx. It's the implicit differentiation. And this side will be 1. When we take cosine y over here, you will have dy over dx equal to 1 over cosine of y. You have these identities, which is sine square of x plus cosine square of x will be equal to 1. So you will plug it into this one, and you will have 1 equal to 1 over 1 over square root of 1 minus sine square of y. Now we have over here is that sine y is equal to x. So which means this one will be x squared. So it will become 1 minus x squared. So in the end, you will have that the derivative of the inverse function of x with respect to x will be equal to 1 over 1 minus x squared. The same thing will be happening with the cosine. So for cosine, you have the graph of it looks like this one. One over here, 5, 2 here. So the graph will be like this. Oops. Which means the range of y in this problem will be 0 to pi, which will lead to the definition of the inverse function of cosine will be cos y equal to x, and the range of x, as I mentioned earlier, will be from 0 to pi. And with the same way as you proved with the earlier one, with the sine one, you'll find that the derivative of x will be equal to minus 1 over 1 minus x squared. X will range from minus 1 to 1 because of the square root requirement. Okay, so the rest of the function will be found in the book that you provided in page for tangent. The problem with tangent is because the range of y in tangent would be minus pi over 2 and pi over 2. As I mentioned earlier, the range of the function is very, very important because when you do the problem, when we solve the problem, the value, the solution of y must be in the range provided by this. So make sure that every answer that you make, the answer will be range in that correct range in the textbook. You can find the rest of the formula in the textbook in page 479. The most two important integral of the inverse function should be these two. So you will have that this one is the tangent, the graph tangent. So you see that the line x equal to minus pi over 2 and the line pi over 2 is the vertical asymptotes of the graph, uh, which mean that the limit of x of 10 when x go to infinity of inverse function of 10 will be equal to pi over 2. And if x go to minus infinity of inverse function of 10, it will go to minus pi over 2. You have this one because the inverse function of 10 will be y. So that means you have 10 y equal to x. And when you plug y into this, you see the result. Oh, actually, I'm so sorry. This one is a mistake. So you have that. This is the graph of the tangent of x. So which mean the inverse function graph of tangent will be like this one. So which mean the this which mean that the two line x which mean that the inverse function of tangent is bound by the line y minus pi over 2 and pi over 2. So for both cases, we will lead to the assumption that the limit of x to infinity of tangent of the inverse function of tangent will be equal to minus pi to pi over 2, and if it is x go to minus infinity, this one will be minus. So for the integral, there's two equations that you must remember because it will be very useful for later use in the course. So the first one will be the integral of, it is very useful in the course. So you're gonna use this one a lot. 1 over 1 minus x squared dx will be equal to arcsine of x plus a constant. This one is because we have just proved that the derivative of the arcsine will be equal to this one. The second one will be 1 over 1 plus x squared dx equal to tangent arctan of x plus c. These are two very, very important equations that you must know. So let's go with some example in the book. Yeah. The first one is, let's go to the reverse tangent. The first problem is, let's say that this one is example 2. You will have simplify. This one is a very tricky question that it will also appear on the exam. So simplify this equation, this expression. So the first way to do this one is, I've already mentioned it earlier, by using a triangle and the Pythagorean, sorry, using the Pythagorean theorem. Sorry, because I keep like forgetting this word. So Pythagorean theorem to solve this solution. And it's fairly easy to do this by that way. So if you let inverse tangent equal to y, which means that tangent of y will be equal to x. So that means when you draw this triangle and you have y as the angle over here, you see that tan y will be equal to x. So which means this side will be 1 and this side will be x, which leads to this side will equal to 1 plus x squared, the Pythagorean theorem. Which means that this function right here will equal to cosine of tan y cosine of y and you have in this triangle right here, cosine of y will be equal to 1 over this line over this line. It could be 1 over square root of 1 plus x squared. This is the first way that you can do it, but there's a second way which you won't have to draw any triangle to do this. The second method will be, you know this equation, secant square of x will equal to 1 plus tangent square of x, right? So, which will lead you to the problem. You still said that inverse tangent of x is y. So tangent of y will equal to x. So when you plug this one into this equation right here, you will have that secant square of x will be equal to, of y, sorry. Will equal to 1 plus x squared. So secant of y will equal to square root of 1 plus square root of 1 plus x squared, which And you know that secant of x is 1 over cosine of x, which means cosine of y over here will equal to 1 over 1 plus x squared. Sorry. Cosine of y will equal to 1 over square root of 1 plus x squared. So there you go. Here's the second solution. And for me, it would be easier because you won't have to calculate the Pythagorean theorem. And that's pretty much it for the 6.6. We will now go to the 6.7. We'll go to the 6.7 section. So all the necessary equation is already there in the book that if you skim through, which is on the viewer, like they all have it on in the book right here. And all you need to do is remember the hyperbolic identities and the definition of the hyperbolic functions. The only problem that you would tackle, which is a little bit like harder, will be the inverse function of this hyperbolic function. So which means you have that. So for example, that's sine hyperbole of x will equal to sine hyperbole of x will be equal to e over x. Sorry, e to the power of x, and e to the power of minus x over 2. And it is because this one, the hyperbolic function, is a function of e. So it means that the hyperbolic function, the inverse hyperbolic function, can be expressed in terms of logarithms. What that means is that this sine hyperbole inverse of x, the board is very hard to use, will be equal to x plus square root of x squared plus 1. So how can you prove this one? How can you prove that inverse function of sine hyperbole of x will be the logarithmic function of x? So to prove this one, it's fairly easy. Like it's just basic algebra. So you should be familiar with all the inverse function problem because you have to do this thing all the time. And let y equal to sine hyperbole of inverse function of x. And so which means that sine hyperbole of y will be equal to x. Which means by definition of this one will be equal to e of y minus e to the power minus y over 2, right? And you take the 2 and move it here. It will be equal to 2x equal to e to the power y minus e to the power minus y, which will lead to e to the power y minus 2x minus e to the power I equal to 0. And to solve this equation, right here, you multiply both sides by e to the power y, which leads to e to the power 2I minus 2x to the power e to the power I minus 1 equal to 0. So we treat 2x as b, and this one is c, and there's 1 times over here, so the 1 will be a. So this one is a quadratic function. You have the to the power 2 over here, e to the power I, y over there, and 1. So when you solve this, it will lead to e to the power y equal to 2 e to 2x, which is e, and this is the simple quadratic function, like how to solve 4a squared. Sorry?
Hey, is this but that's, we have a video session at 5.
Oh yeah, but like 10 minutes.
Yeah, okay, great.
for x squared plus 4 over 2. Which can be simplified to x plus x squared plus 1. Oh, yeah. But because this one right here is larger than square root of x squared, which is equal to x. So which means this whole function, if it is x minus square root of x squared plus 1, it will be less than 0. And e to the power of I over here is always larger than 0, which leads us to the only solution of this one is x plus. Session.
On that side.
Oh yeah. Square root of x squared plus 1. Why is it so hard to use? Oh, that's not.
This is recording.
Yeah, I'm recording. But usually this really is hard to.
Here, try this.
Oh, that should be easy. So it shows that y.
Oh, that's much.
Never mind. So which lead to y will be equal to the logarithm of x plus x squared plus 1. And that's it. So if you have any further question, you can email me after this one about 6.6 and 6.7. This Thursday, I will have the session review session about 6.8 and 6.9. Okay, thank you. Oh,
Okay. Okay.
oh yeah.